what you'll start with is a finished foundation, right? Just a plain foundation. You'll have rebar coming out of the concrete. That's what's going to connect the wall to the foundation. The rebar can typically put in before the pour, so it saves a little labor there. Sometimes they'll actually drill it and use an epoxy to set that rebar, but this is how you're connecting the wall to the foundation. This board right here is simulating the foundation. This is the glue foam I was telling you about. It's an off-the-shelf product that's used for all sorts of different plastic products. But all he did is he put a bead down on the foundation, set the block over the rebar. He also puts glue between the joints, so the glue just temporarily holds it together. Once you got it all set level, you don't want anybody to get it out of plane, so it just keeps it all locked together. Ultimately, it's the concrete, because wherever you got two blocks coming together, there's always concrete. The concrete grows, kind of seeps into the pores of the block and locks that together. The glue really doesn't do anything after the concrete's in there. So you imagine you start at a corner and you go all the way around. You've got this half pour exposed always. You lay your horizontal rebar in there as you go. So use these chairs. You always want to keep the rebar in the center of the pour, right? So you're just going to chair those up. So we're just going to get up to this next course. This is what they call a snap. Go ahead. This is a snap tie, and we'll show you how that plays. That's part of your bracing system. One of the things when you're building a wall, until it's all in and the roof is connected all together, you got to brace it to keep equipment from bumping into it and knocking the wall over. This is very standard, same thing they use for concrete construction. So literally, I mean, he's doing exactly the way you're going to do it on site. Once you get that first course set, you may have some variation in your foundation. You may actually have to shim it up a little bit to try to get out some of the unevenness. You're going to use just a wood shim, right, like you normally would. One thing you don't want to do is you don't want to shove it into the block, because remember, this is foam. You're just going to compress the foam. So what you have to do is you actually have to tilt it over and set it in there and get it shimmed. So you got to set a level to that and get it all nice and plumb and true. And typically they work in two-man crews. There's a guy gluing and a guy bringing block. They have a third guy going over there and cutting block. There's a couple of conditions where you're going to cut the block, and we'll show you about that in a second. But as fast as you can glue it, get it set, level, plumb, straight, you can go. One thing I didn't mention, you notice there's no vertical rebar here. You're always going to have vertical rebar. But what I don't want to do is have to lift those blocks. Say I'm going to do a 13-foot tall wall. I don't want to have to lift those blocks and put them over that, so we add that later. What we've developed here is a new system. There's two tie wires right here. Basically, it goes around the foundation coming out of the dowel, and the horizontal that's at this level right here goes around twice. When I get that wall all the way to the top, I'm going to take that rebar and I'm going to drop it in here. And then I'm going to take pliers and I'm going to pull that, and it's going to cinch all three bars together. And that keeps it directly in the center this way, directly in the center this way. You get a fully tied cage. And then at the top, I'll also tie them all together. And that keeps all the rebar going. So these are the chairs again to get the rebar at the middle part of this floor. This is a window butt. There's a couple of ways to attach windows to this wall system. I'll build a wood butt like this to the dimensions I need. I'll measure the inside dimensions, and my window system is going to fit on the inside of that. I can set this up in the wall. I can have lag screws stuck in the back of this. You ready for this? And basically on all four sides you're going to have concrete up against this wood butt. So those lag screws get captured by the concrete, right? So that permanently affixes this to the wall. If you don't want to leave wood in the wall, if that's what if the architect wants concrete to attach to, you do the same thing, except your finish openings to this side of the butt, and you don't put the lag screws back there. You put a release oil on here, so that when you stack the wall up, fill it full of concrete, you just take that wood out, and now you got a 6-inch concrete surface to attach to. So you can do it either way. And there are metal butt systems that come from a factory already made that you can just set into the wall, and the concrete captures that into the wall. And then you can attach your windows and doors to that.
And it'll always be the same thing. You want your window and door butts so you can set them in place and build to them. You don't ever want to have to wait, leave a gap to put your windows in. You want to have it there so you can build it in as you go.
So one thing is, on this wall, of course, it courses out perfectly. I don't have to cut any blocks to get right up to that window. Dwayne designed it that way to make to build that corner. We're going to show you a corner here in a second. Yeah, that's a good question. But let's say that I had to actually cut this block here to get it to match up to this window. So it's not a perfect 16-inch module. Say it comes in at 12 inches. What I'm going to do is I'm going to take this block and I'm going to cut it. I'm going to cut it short. I'm going to cut it all the way through this block. Now I'm going to have a finished. It's going to be a flat surface there, right? Well, that same tool, I'm going to use an electric chainsaw to cut this way. I'm going to come back in and I'm going to cut this out and create a new column. And I just take this material out. Now I can stack this block up there. So you don't have to worry about it getting perfectly on 16s into the wall. It's very flexible. You just cut it to size and add back. What you don't want to do is you don't want the vertical columns to exceed 16 inches. So it can be 16, 16, 16, then 9 or 12. We're going to show you also, he's already pre-cut some block. Say you have a large opening over a window. There's a lot of weight still. There's still a lot of wall over this window. If you don't have enough structure here, it'll cause this window to sag. So what the engineer will look at is creating a larger beam across here, or a lintel in here. And that's all formed on the inside of the block. Sorry. We call this the shoulder. Right here, the 2-inch shoulders. The 6-inch portion in the middle we call the meat. Okay? So in this case, what he's done is he's gone ahead and taken that chainsaw and he's cut out this extra material. Now that's just going to make more room for concrete. We're going to set this over the window. So whatever the engineer needs as far as concrete to span an opening, you can manufacture out of our block. You just cut it out, lay it up there. Probably going to call for more rebar too in there, so it makes it nice and easy to get up there.
Sir, I have a question.
Yes, ma'am.
In the residential area, a lot of homeowners change their minds later, like they want a bigger window, or they want a bigger window, a bigger door. How difficult is it to make those changes?
Before the pour or after the concrete? It's more difficult than with framing, but not as hard as if it was a CMU system. You're still going to have to cut in and course on. Going to go into specifics if you want to, but you're going to have to cut it out larger. You're going to have to account for that. So there's a little bit of a...
There's a couple ways to do it. If you're not concerned with the extra weight over the top, it's just a matter if you wanted to make this, double this window width, just measure over and cut. You have to cut through the horizontal cord, but you still have one attached to it. So this cord, if there's a concern with making the opening wider, carrying the weight from above, you may have to add a steel panel underneath to help carry the extra weight, since you won't have the heavy beams come across. But they can be done.
Essentially, you've got a beam and a column every 16 inches from the center, so it actually does make it a little bit easier. You can now rely on that. You may have to come back and augment it. It's certainly not as easy as ripping wood out and starting over, but it's not as difficult as it is with other concrete systems. So Dwayne's adding the second snap tile. Basically, we're gonna brace this about every 12 feet or so.
That happens.